back. What two things affect force? Well, it's what's in the equation. Force equals mass times acceleration. That means mass and acceleration affect force. And we saw in that video when the kid hit the ball and he hit something with a small ball like the softball, the acceleration was greater. When he hit the thing with a large mass like the shot put, the acceleration was small. Okay? So what is Newton's second law of motion? It expresses the relationship of acceleration to force and mass in the equation. Acceleration equals the force divided by the mass. So when this number on the bottom is big, the acceleration is going to be small. When the number on the bottom is small, the acceleration is going to be big. And then also, the harder you hit something, the bigger the force, it's going to make the acceleration. So that was the example where we said if the mass stays the same and the force increases, like a home run versus a bunt, the more force, the bigger the acceleration. Okay. We already kind of answered this right here. What is the equation for Newton's second law? Acceleration equals force divided by mass. Or sometimes it's force equals mass times acceleration. It's the same equation. What is the force used to move 60-kilogram object with an acceleration of 30 meters per second squared? We need our FAM triangle, force equals mass times acceleration. Okay, it says what is the force? So that's our question. We're going to put a question mark in the force box, and it gives us the mass. It's 60 kilograms. So we're going to put 60 kilograms in the mass box, and we know if the numbers are next to each other on the bottom, we're going to multiply. And it says it has an acceleration of 30 meters per second. So squared. So we're going to put that in the A box. The numbers are next to each other on the bottom. So we know we're going to multiply. So this literally says F equals 60 kilograms times 30 meters per second squared. Okay. So 30 times 60 is 1,800 newtons is the unit for force. The third law of motion is for every action, there's an equal and opposite reaction. Okay. And fully describe and explain an example in Newton's third law. When a ball hits the floor pushes back on the ball with the same force. If the force didn't push back, the ball would just go in and keep on going down like it was falling through the air. So here's a little picture. The ball is going down. There's nothing to provide an equal and opposite force, so it just keeps going down. Finally, it hits something that it can't go through. Okay, the ball pushes down, and the floor pushes back up on the ball with an equal and opposite force, and then the ball bounces up. And when we pick up next time, we'll be starting a new unit on working machines. I hope you're having a great day, and we'll see you soon.